No, please don't turn me into an NES game, no! Hello, DevGod here. And you might be wondering, how is this possible? How is it possible to get a VTuber onto an NES game? Well, I decided that I'm going to show you guys a little behind the scenes on how I was able to do it. So usually, I go ahead and use the VMagic Mirror since that is my preferred vtubing software of choice with the nice, mouse-based tracking movements, but I wanted to challenge myself. I wanted to see if it was possible to somehow, put myself inside of an NES game. So yeah, that is what we basically did. So to give, an overview, what I was able to do is I went ahead, got a couple of tools right here. So one of the first things I did, right, was take a picture of myself. Picture of myself with my mouth closed and everything. Then I turned it into a BPM, right? Image quality gets a little bit more cursed as we go. And then eventually I've shrink that to I believe 160, I don't know, a really low resolution, so that way I could fit all the tiles that I wanted to while I converted. And so that's the image I had left over. So then what I went ahead and did is I imported that BPM into this really cool tool called the NES Screen Tool. This has been around for a while. This lets you edit tile sets. This lets you kind of preview name tables, pallets. It basically lets you preview graphics before you're able to export them in a format that you can compile in an NES game. So I went ahead, put my colors here. I made some slight adjustments to the tile set, but overall it's pretty much the same as this picture right here. And that is the name table. So then once I got done editing that, I went ahead and exported name table, the char file. So basically your name table, which is what this is right here, I was able to export it as a header, as I believe a C header is what I believe it's called. And yeah, so basically the name table is where your tiles are stored at a given time, something like the NES can kind of do. And then your char, your CHR, or your pattern table, as some people call them, is where the actual graphic tile set is stored by the NES during gameplay. I'm probably really not describing this very well, but I mean, in essence, that's kind of what it is. So we got pattern table, we got our tile set here, we got our name table. So then once you use this NES Screen Tool to get that all exported into a format that you can use, you are then ready. See, let me make sure my VTuber mouse there. You are then ready to go ahead and create, to start coding some fun stuff, some very fun stuff. Also, I hope you guys really do love my Windows XP crispy JPEG background we have in the background there. So anyway, one of the things I found out is I used to like ASM NES games, but I figured out how to use the a C library called NesLib. And I also started exploring. There's a guy named NES Doug, who has a lot of really good documentation on how to program for the NES and retro programming in general, but especially the NES. He has a very cool blog going on to give you guys more information if you're curious, so go check him out. And yeah, so I got these two C libraries. Here's the H file in case you guys want to see it really quick. So it's basically just redefine some things that the NES will want to use, like how to clear the PPU, how to do some things like that. How to read controller inputs, a lot of fun stuff. What we go ahead and do is we define some colors, which I don't think I actually used these in the final game, but I was using those for something. We do the 0 page, declare some of our variables that I use, and again, I'm kind of a beginner at C, so this is a little bit messy code. I'm definitely a web developer at heart, not a very good retro developer, but I managed to do it. I put some hello world text. I think I was testing how variables, specifically char arrays, work. And yeah, so I was able to go ahead, get the palette. So this is basically the palette. This is what controls your NES colors. So as you may know, if we're looking at the NES Screen Tool, the NES can display 4 colors at a given time, and then can also store 4 different palettes to switch from at a given time for use with the name table. So that's how, for example, my dress is able to be black, dark green, light green, and then the bow is able to be kind of different shades of orange, and how my face is able to have red hair but blue eyes, for example. So it all is about those palettes that you can swap them, but you can only have 4 colors per each palette, and you only get 4 palettes at a given time, or at least with the original NES and NES cartridges. Then I just like to find the C headers in here to make it a little bit easier for myself to not have to like include stuff in the C script. This is probably not good, it is kind of messy, but this is just what I did to be quick. Just copy and pasted the name table C headers to be on the same script as my actual game code. So this basically is data about like how to arrange the tile set. And that is for both the, you know, the silent picture and the talking pictures. I have 2 pictures. It's basically a 2-frame game right here. Then I have a draw, which does things like turns the PPU off, controls like the palette background, loads that palette up, lets me like draw to the name array, and I do have that in a couple of different ways, but this is kind of like how I do it right here. I'm able to use a function called VRAM unrel, which basically takes these and like decompiles it. In essence, I'm like probably oversimplifying this, but decompiles this into a way that the NES can use it to actually arrange like the tile set to actually display on screen. So it's like a really fast way of doing it. And of course, we're defining our name table in the VRAM address. We got our PPU on. So this all happens while the PPU, which is like the graphics processing unit, is turned off. And then we have these. So this is basically just me manually editing memory values. Again, this probably is not the best way to do it, but these memory values, these 2 things in RAM, are dedicated to controlling the APU, which is basically the audio processing unit. So this is how I'm able to get like the little like sound effects kind of going on there. Yeah, and then last but not least, I have my main void. This is the void that's going to be run like throughout the whole game. So we do an initial draw, but then we go ahead and do like a while infinite loop. We do some wait nim, which for those who don't know, nim is basically a maskable interrupt. I believe that's what it's called. Don't quote me on that. And that's basically the period when game code can be run because the PPU is not actively drawing stuff to the screen. If you try to like run game code, and you're like, you know, outside of it, like a non-maskable interrupt, things can get pretty broken pretty quickly, so we go ahead and put that there. Then we just have like pad 1, which is going to represent our controller 1. In my case, since I'm using an emulator, technically my keyboard, since unfortunately I don't really have any USB NES controllers at the moment, but I mean, same thing. And then if the controller is plugged in and the state is not equal to 0, then we go ahead and switch and basically have this here so that I can switch from like the talking state to like the mouth quiet, you know, shut state. And depending, so as soon as I press the any button on the controller, one of these if statements will sound. So for example, I press the A button, it'll set myself to talking. As soon as I let that go, the pad will be set back to false, and then therefore this will run. So that way state is set back equal to 0, and then I basically go back to quiet. And that's basically all of my NES code and all of my NES, you know, tile sets and name tables and stuff. So then eventually I use GCC, or no, I don't use GCC, I use CA65, which for those who don't... Okay, we are back, so I have brought up the official CA65 documentation. I have an offline copy of this somewhere, but I thought I might as well go ahead and bring it up. So this is basically a really cool assembler slash compiler for the 6502 base systems. And this you can really use for anything that use like a 6502, which is basically, you know, classic computing. So your NES used it, your C64 or Commodore 64, your Apple II. Pretty much everything imaginable in the 80s either used the 6502 or something very similar to a 6502. So a lot of usage was used in the 80s, and then also some other ones like 6502C, 65816. Got a lot of interesting stuff, but this is the tool that I went ahead and used. Really good command line tool. So I was able to use CA65 to export this as a .NES file and compile it and everything and assemble it. Oh yeah, other notes, CA65 can be used to assemble like .asm files, so actual assembly if you want to go like very low level. Or if you're like me and you wanted to go for the using a C library and C code, it can also compile C code into retro games as well and retro programs, so you do got that there. And anyway, yeah, this is our finished result. You know, just to show that it is working, I do have this here. Okay, so this is our finished result, so we go ahead and launch the game, and basically the first thing that we see is, you know, a little bit of a quiet DevGod kind of staring into the camera. Kind of looks cursed, but I try to do my best as much as possible with the with the graphics here. And anyway, so you can click like any button. I'm just gonna click like the up arrow on my keyboard since that's like the up on the D-pad or whatever. And then there we go. We have movement. Like press that as many times as I want, and yeah, so we have like a really cool talking animation. That is basically how you can become a VTuber on the NES slash Famicom. I hope you guys like this interesting little video, and yeah, see you guys next time. Peace.